Number 16, you're supposed to find the area under the curve from 0 to 4. So to do so, we're going to integrate this function with respect to x from 0 to 4. So to integrate e to a linear function, I'm just going to rewrite this to show you that's what this is. X over 2 is the same as saying 1/2 times x. I believe that's an easier way to look at it. Integrate this, you take the reciprocal of the 1/2, which would be 2, and then multiply it by the original problem, e to the 1/2 x. We're evaluating it from 0 to 4. Which means we're going to put 4 in for x, and subtract from that, putting 0 in for x. It's 2e to the 1/2 times 4 minus 2e to the 1/2 times 0. Half times 4 is 2. Half times 0 is 0. 2 to the 0 is 1. 1 times 2 is 2. So it's 2e squared minus 2 square units. That is the area under this curve from 0 to 4. Number 17 says the company's marginal cost function is the following, which you see here, where x is the number of units and the fixed costs are $20,000. Find the cost function. Well, to find the cost function, we're going to have to integrate the marginal cost function. So we're going to find the antiderivative of x to the negative 1/2 plus 4 with respect to x. It's going to give us, we had 1 to the exponent, the x to the 1/2, multiplied by the reciprocal of 1/2, which of course is 2. Add to that, the antiderivative of 4 would be 4 times x. Since we don't have a definite interval, we don't have an upper and lower limit, and that means we're going to have to throw in an arbitrary constant. This is our cost function, but we do not want this arbitrary constant in this problem. If I read this problem to you again, it mentions, well, at least part of the problem, fixed costs are $20,000. That means when nothing has been produced, it's costing them $20,000. When x is 0, the cost is $20,000. That's an ordered pair. 0, 20,000. So to figure out what c is, this arbitrary constant, the c right here, we're going to put $20,000 in for c of x, and we're going to put in 0 in for x. See what c is. Square root of 0 is 0, 2 times 0 is 0, 4 times 0 is 0. So that gives us, coincidentally, that our constant is 20,000. So to answer the question, what is the cost function? It's c of x equals 2 times the square root of x plus 4x plus our constant, which is not arbitrary, of 20,000. This is the answer to the question. 18 says a homeowner installs a solar heating system which is expected to generate a savings at the rate of 200 e to the 1/10 t dollars per year, where t is the number of years since the system was installed. So we're saving money every year after the system's been installed. It says that t is how many years since you've installed the system. So that means at time 0, we have saved $0. That's an ordered pair in this problem. It's very important. Part A asks, find a formula for the total savings for the first t years. Well, let's define our variable, and let's say that t is total savings. So therefore, t, you know what, don't want to use t. It's confusing because we have little t's in the problem. Let's use an s for savings. So our savings is going to be integrating this rate, 200 e to the 1/10 t with respect to t. If we integrate this, the reciprocal of 0.1 or 1/10 is 10. E to the 0.1 t stays the same, plus arbitrary constant. Therefore, S of t is 2000 e to the 0.1 t plus c. If I use our ordered pair that we figured out at the beginning, 0, 0, and we put 0 in for total savings, we put 0 in for how much time has elapsed, this will help us figure out what c is. 0.1 times 0 is 0, e to the 0 is 1. So this is 0 equals 2000 plus c. Therefore, c is negative 2000. Hence, if you will, to answer the question, find the formula for the total savings. S of t equals 2000 times e to the 1/10 t minus 2000. This is in dollars. So there's part A. Part B says, if the system originally cost $1,500, when will the system pay for itself? What the question is really asking you is, at what point will you save $1,500? Once you've saved that much money, then you can take that money that you saved and say, well, I can put that towards me buying the system. So at this point, I've broken even, essentially. So if we replace S of t with $1,500, and then we're solving this equation for the variable t. If we add 2,000 to both sides, we get 500 equals 2,000 e to the 0.1 t. If we divide both sides by 2,000, we get 500 over 2,000 equals e to the 0.1 t. Now you can do some canceling here. You can divide top and the bottom by 100. And you can divide both 5 and 20 by 5 and get 1/4. This is actually 1/4 equals e to the 0.1 t. If you then apply natural log to both sides of the equation, why would you want to do that? Well, the whole point of logarithms is to solve equations in which your variable is locked up in an exponent. 0.1 t and point t are the same thing, but I don't want to cause confusion, so let's put that there. Now there's a rule for logarithms that says if your argument, this here is your argument, e to the 0.1 t. If your argument consists of an exponent, you're allowed to take the exponent and move it so it's a coefficient, which means we can take the 0.1 t and we can write it in front, like so. Now hopefully you know what natural log of e is. That's just 1, because it's essentially saying log base e of e, which literally means e to what exponent is e? Well, it's 1. If that's 1, we want to get t by itself. Right now we're multiplying it by 0.1 or 1/10. To get rid of that, we could multiply both sides by 10. So we get 10 natural log of 1/4 is t. Put that in my calculator. I get a negative answer, which tells me that I made a mistake. That hurts a little bit. I'm not going to lie to you. Messing up at this point is a problem. And I look, and my mistake is, wouldn't you know it, the very first step, this is not 5,000. If I add 2,000 to both sides, that's going to give me 3,500. I'm sorry. If we had 2,000 to both sides, 2,000 and 1,500 is 3,500. Boy, I just made a complete fool of myself, didn't I? Then, if we divide both sides by 2,000, we get 3,500 divided by 2,000 equals e to the 1/10 t. You can once again divide the top and bottom by 100. 35 and 20, you can divide both of those by 5 and get 7/4. If we apply natural log to both sides of the equation, like so, once again, this exponent for the argument we're allowed to write as a coefficient of natural log. So we get natural log of 7/4 equals 1/10 t times natural log of e. And once again, natural log of e is the same thing as 1. So if we then multiply both sides by 10, we get 10 times natural log of 7/4 equals t. Let me put this in my calculator and let me hope that I get a reasonable answer. If I don't, I will probably take my iPad and throw it out the window and call it a night. Lovely. I got approximately 5.6 years. And that answer is part B. 5.6 years.